Welcome to this presentation on time series forecasting. Today, we compare three powerful models: autoregressive integrated moving average, ARIMA, error trend and seasonality, ETS, and neural network autoregressive, NNAR models to answer a critical question: which model delivers the most accurate forecasts? Our study focuses on monthly rainfall in the UK. We'll evaluate each model's performance using real-world data, statistical diagnostics, and forecast accuracy. This work is presented by Michael, a consultant in research, statistics, and data analysis. Here's the rainfall data from 2018 to 2024. Notice the fluctuations, peaks, troughs, and possible seasonal patterns. This visual gives us our first clue. The data is dynamic and potentially seasonal. This seasonal plot reveals rainfall behavior across months and years. We see recurring patterns, some months consistently wetter than others. Seasonality is clearly present, and our models must account for it. The subseries plot breaks rainfall down by month. It shows intra-year variability and highlights which months deviate from the norm. This helps us understand the structure of the data before modeling. Before modeling, we check for stationarity, a key assumption in time series analysis. ACF and PACF plots suggest stability. Statistical tests, ADF and KPSS, confirm the data is stationary and ready for modeling. We also test for structural breaks, sudden shifts that could affect model performance. Using QLR, CUSUM, and MOSUM tests, we find no significant breaks. This means our data is stable over time. We split the data into training and testing sets using the 80-20 rule. ARIMA 001, 200, 12, ETS, MNA, and NNAR 112, 12 are selected based on the lowest AIC values. Each model is tuned for optimal in-sample fit. We assess ARIMA's assumptions using residual plots and statistical tests. The residuals pass the Box-Pierce, ARCH-LM, and Shapiro-Wilk tests, indicating a well-behaved model. The ETS model also passes all diagnostic tests. Its residuals show no autocorrelation, no heteroscedasticity, and approximate normality. This confirms ETS is statistically sound. NNAR's residuals meet the same criteria. Despite being a neural network model, it behaves well under statistical scrutiny. All three models are valid, but which one performs best? We compare models using rooted mean squared error, mean absolute error, mean absolute percentage error, and mean absolute scaled error. ETS model outperforms both ARIMA and NNAR models across all metrics. Diebold-Mariano tests confirm these differences are not just present, but also statistically significant. Even when forecasting unseen data, ETS model remains the top performer. Its predictions are more accurate than those of ARIMA and NNAR models, even when NNAR is tuned to 51412. ETS model proves to be both robust and reliable. In conclusion, ETS model is the most accurate model for forecasting UK rainfall. We recommend ETS models for similar time series tasks. Future research should explore whether ETS model maintains its edge in other regions and datasets. Thank you for watching. If you're passionate about data, modeling, and evidence-based forecasting, this is just the beginning.